Ashley has to take it. Lydia has to take a test. And so everything has to be done by tomorrow or else it's a 0. And then I'll put them all in. Okay. So you guys are definitely, I'd be shocked if you weren't good at long division, but I do need to know, does anybody use the box method? Please say no, please say no, please say no. Good. Good, because I don't do the box method. So.
Oh, I remember that.
Yeah.
I don't use it.
Remember long division, obviously, if you're dividing by 15, you start with, how many times is 15 going to 84? Ryan, your talking is bothering me. Please stop. We need the whole number. 6 is too much because 6 times 15 is 90, so 5. So that's 75. And then we do subtraction. 84 minus 75 is 9. Bring down our 2. And we repeat. 15 goes into 92 6 times 90. Now, do you remember in elementary school, the very first thing you ever did was you would say remainder 2? Remember that? No. And then what you probably eventually learned in elementary school is to add a decimal, and you put a decimal up there, and you would bring down your 0, and you would keep going and make it a decimal. Do you remember that? You don't remember that? It's probably been a while. I'm almost positive you did it in elementary school. Then you would do 15 times 1 is 15, and you would literally just keep going until you got something that was repetitive, or till you got something that worked out perfectly. So you've got a 5, bring down your 0, 15 goes into 50 3 times. And here's where the repeating is going to start, because 50 minus 45 is 5 again, and I'll just keep bringing down to 0, and it'll keep getting 50. And so that's how you know what's going to start repeating. You keep getting 3 over and over again. 45, 50 minus 45 would be 5. You bring down to 50 again. So that was the second step. So that rather than doing 56 remainder 2, you then took it to a decimal. And then going back to that 2, you would really do a 2/15, right? A remainder of 2 out of 15 would be 56 and 2/15, which is what that decimal is anyway, right? 2/15 apparently is 0.13 repeating. So whether or not you remember all that, you definitely, because it's much more fresh, remember long division, starting with dividing out an x minus 1. And then you start by asking yourself, and you only use the leading term of your binomial. So x times what gives us 3x squared? Or 3x cubed, rather. 3x squared, sorry. And then when you do the multiplication, the same multiplication that we did when we did up here, 5 times 15, you multiply that 3 by the entire binomial. So 3x squared times x lines up as 3x cubed, and 3x squared times negative 1 lines up as negative 3x squared. Now here's where the majority of the mistakes will happen, because people will put their minus sign out in front, and they'll forget the minus sign when they're doing the next 2 terms. So my answer to that is to just put a minus sign in between every single set of corresponding terms. It just makes, not that people don't still screw that up, but it makes it a little less likely. So your 3x cubed minus 3x cubed, of course, is gone. And negative 2 minus a negative 3 turns into negative 2 plus 3, which is just 1x squared. And then, just like we did with numerical long division, you bring down your next term. What would go up top next, Mike? Are you doing this into that? We do this into that. Okay, so you just pick up where we left off as if it's a new problem. Positive x. Right? X times x is 1x squared. You want it to match exactly. Did you think you wanted it to be an opposite sign? Okay. So x times x minus 1 is x squared minus x. Again, put your subtraction in between each and every set of terms. X squared minus x squared is gone. Negative 4x minus a negative x is negative 4 plus 1, which is negative 3x. Bring down your 5. And then the last term up top, okay, negative 3, good. Negative 3 times x minus 1 is negative 3x plus 3. Throw your subtraction symbols in there. That cancels. 5 minus 3 is 2. And you know you're done because x times what goes into 2. You can't do without a negative exponent, so you're done. And that's your remainder. And so the way we pick up remainder is just kind of piggybacking off of our numerical example is you put your last number, which up here was when we ended with the 2, over your divisor. So in this case, it would be 2 over x minus 1. Now with mixed fractions, you don't need to do 56 plus 2/15. When we say 56 and 2/15, we don't need a plus sign in there, even though that's kind of how you would have to type it into your calculator. So, but here with a polynomial, you essentially have a fourth term that you need to add on to whatever your quotient was. So, a couple things to remember. Since we have a remainder, what can you tell me about the relationship between x minus 1 and the original polynomial? It's not a factor. Exactly. So x minus 1 is not a factor of that. Any questions? Does anybody know how and or remember how at quick glance you can tell me whether or not x minus 3 is going to be a factor? Oh, yeah. Plug in 3. And if 3, when you plug it in, gives you 0, it should be a factor. So if I plug in 3, it's going to give me 27 times 2, 54, minus 9 plus 3. Doesn't go in, right? What is 54 minus 9 plus 3? 48? Okay, so when it's not 0, but that 48 is telling too, right? Because what should happen? Where's that 48 going to come up again? As the remainder. It should. So if you know that fact, you can use that fact to sort of check your long division. Because if I do long division and I get a remainder of 35, I don't really know if that's right or wrong if I'm not using that. I just kind of hope that it's right. But if you know what you're supposed to be getting, it can give you good guidance. Now, with that being said, because I don't love these 4 examples, I want to change that x minus 3 to 2x minus 3. Because I noticed when I looked at these 4 examples, they all had a leading coefficient of 1. And I don't really want to go that route. So what should I plug in to see what my remainder should be? 3/2, exactly. Whatever, when I tee this up and solve for a root, whatever that root would be, that's what I plug in. So, good, you guys remember this pretty well. So 3/2, I would plug in 2 times 3/2. I'm not going to try to do this one in my head. Minus 3/2 squared plus 3. So I should be targeting a remainder of 7.5. We'll see how that pans out. I'm a little afraid of that. All right. This might be an interesting conversation. See what happens when you make up an example on the spot. Okay, so I'm going to do my long division. Do you notice anything else different about this problem other than I just inserted a leading coefficient? Allie? Right, we're missing a 0x term, which will affect how things line up if we don't insert a 0x. So you can work around not doing that, but it's going to be more trouble than it's worth. So if you realize that, put it in there. Now everything should stay lined up. So, Rock, you're my guy. What goes up here? Did I catch you with a mouthful of Cool Ranch Doritos? I knew I should have stolen them while you were out. They smell so good. Go on. x squared. So 2x times x squared gives us 2x cubed. I don't find it that funny, Brock, because I work with you kids all day long, and people say that all the time. Minus 3x squared. Do your subtraction. And first term, if you pick it right, will always cancel. And then negative 1x squared minus negative 3x squared is negative 1 plus 3, 2x squared. Oh, so far so good. What goes up top next, Carolina? Yep. Good. 2x times x gives you 2x squared. Negative 3 times x gives you negative 3x. Throw your subtraction in there. And 0 minus negative 3 is 3x. Oh, this is why the problem. That's okay. I know you're gonna die if I tell you this, but we can figure out 2 times what gives us 3. 2 times what gives you 3? How do you solve this for the question mark? Divide both sides by 2. So 3 halves it is. So we're going to add 3 halves. 3 halves times 2x is 3x. And 3 halves times negative 3 is negative how many halves? 3 halves times 3 is how many halves? This is amazing to me. This is amazing to me. Yes. You guys, we need to pause because multiplying fractions, especially when one is a whole number, should be the easiest thing on the planet, but you melt when I say it.
9 over 2.
So 5 times 5 halves is 25 halves. 8 times 9 halves is 72 halves. Yeah? Not that hard. If you know your times tables, which I know you do, and this immediately throws you. I mean, the fact that you passed an Algebra 2 exam, I sure hope you do. True. That's true. That's a really good point, Ellie. All right, I take it back. We're going to have a times table quiz tomorrow. I'll give you 100 in a minute. See how many you can do.
Yeah, let's do it. Let's do it. You got quick math, dude. Come on now.
If I'm feeling ambitious. All right, so back to the problem at hand. 3 halves times negative 3 is negative 9 halves. Now, if you can't multiply fractions, I am very afraid of adding and subtracting. You obviously do have a calculator, but 3 is the same thing as 6 halves. So 6 halves minus negative 9 halves is 6 halves plus 9 halves, which is 15 halves, which is 7.5. Now, a decimal within a fraction is just as bad as a fraction within a fraction. That's complex. So if I were to add on my remainder of 15 halves over 2x minus 3, what should I multiply by to clear that complex fraction? What is the mini denominator within that fraction? If I'm clearing this complexity. 2. The only the mini fraction within there is 15 halves. The denominator of that is 2. So if I multiply by 2 over 2, that's going to change my, what appears to be my remainder. It is my remainder. That's going to change the numerator into just 15 over, and my denominator is going to be 4x minus 6. And now I have no complex fraction. Now, admittedly, that's usually not going to happen. The only reason we got a fractional remainder is because I made up this problem off the top of my head. But it all worked out. So we good? All right. Try the next one entirely on your own. It is? It is. We'll do that one together. Let me see. So that should have been a plus 3x.
Nope,
Oh,
so
you
multiply.
distribute your negative, so you're just showing it differently than I do. Gotcha. You know what? I would bring down your 7.
Well, I got a minus if I forward.
Yeah, but when you picked your 4x squared, the plus 4 has to line up underneath the 7.
Right.
So if you didn't bring it down, then it wasn't there. So now when you do your subtraction, that'll cancel.
Yeah, that would be negative 2x.
Right, and you're done. That's your remainder. Because once that degree is higher than that degree, you can't. Right. So you're, rather than having a numerical remainder, you have like a linear. Raise your hand if you're done. Raise your hand if you're stuck. If you're not done, just keep going. Why are you all asking me to check it? You were checking, you're walking around. No. Yeah, so you might as well. But if you know how to check it yourself, then you guys. I did. I just wanted to. Okay. So you plugged in negative 2 without get, or you're supposed to get. I said nowadays, right? The chances of you all getting it wrong and getting it math are all right, we have one opportunity for bonus points, so take a moment and see if you can find this person's mistake. And when I'm ready, I'll call on one of you, and whoever gets first. Because it's not dark enough? Hold on. It's what you have. So you probably made the same mistake as what you're saying?
19 is your main.
Mike, pick a number between 1 and 22.
Pick 13 one.
Why would you listen to him? Just out of principle. Just out of principle, I would have said something. He has no idea. He was just being
I am number 13 one.
Well, I gotta find mine. Where's mine?
Oh, you go 13 away from Mike. Pick 7.
I'll pick it.
Pick 7.
Oh, Michael. Laura.
It was 1 away from me.
Right. So right down here, 0. And again, I found like 3 mistakes when I run around the room, and all of them had to do with the subtraction thing. So put your subtraction signs in there so that you don't forget to do 0 minus 10, which would be negative 10, which would cause this to be in minus 10, which would be a minus 20 here. And then when you do your subtraction, 1 minus the negative 20 is 21.
Yeah, I got that. I was kidding.
Laura, winner. Okay, last one. Q sent that back.
Yeah, she really needs
Oh, by the way, there were 2 100s on the
Can we trade points?
You're
The,
about to get 3
quarterly.
All right,
That's what you said last time.
How to get to bonus point? Can I have it?
Okay,
You don't need it, dude. What do you need? You don't need it.
last one, and then I'll give you your quarterly grades back. Why is this one different?
It goes to a square.
Correct.
Get it wrong.
I got it straight up.
So, this is not difficult, although not true. You got confused.
Right.
Okay, so there is some points of confusion that might come up. So, x squared times what gives us 3x cubed? Now, 3x times 1 should not be lined up underneath your x squared term because you'll get confused. It should get lined up underneath your x term. You can put a 0 in there. You don't really have to put anything, but subtraction, subtraction, subtraction. That cancels. 4x squared minus nothing is still 4x squared. 1x minus 3x, negative 2x. So far, so good. Maya, what would come next up here? A plus, do you say 1? X squared times what gives you 4? Yeah, 4. You can if you can foresee that. I didn't. So I'll run into that issue right now because when I multiply my 4 through, I'm going to get 4x squared plus 4, and I have nothing to write it under, so I should have, yes, brought down my 7. So then when you do your subtraction, negative 2x minus nothing is negative 2x. 7 minus 4 is 3. And then again, the only way to do x squared times something to get negative 2x is to use a negative exponent, which is not allowed in a polynomial answer, right? So we're done, and this is our remainder. So I'm sure it can be. I'd have to think about this further. The remainder theorem isn't going to be as straightforwardly useful here. I'm sure there's a way to do it. I would have to think about it because your remainder isn't numerical. Your remainder is linear. So here's a good question. How do I write this? With what sign? Okay. So make sure you do that. That is correct. Make sure you don't, normally if we have a negative remainder, you guys would probably just do like if it was a negative 5, you probably would just do minus 5 over. But when it's a binomial, you can't put your negative out in front because then it would have to get distributed through. So if you wanted to put your negative out in front, this also would be okay. If you changed it to 2x minus 3, it almost would be like dividing out a negative. That is the same thing. Just so if you see a multiple choice option and that's it, know that this and this are the same thing. Okie doke. The one thing we did not get into, because an example did not come up, is if the remainder is 0. So there, let me think of an example. Hold on, just watch me work for a second. I just have to come up with a problem. I've never heard you guys so quiet. You trying to figure out what I'm doing? Oh. Okay, perfect example. Good, good, good. Okay, so let's take something like this, for example, and someone asks you to just factor that. What would you do? You would. You'd go x squared, x plus 3, and you'd pull out -2 probably. Right. Just because factoring by grouping doesn't work doesn't mean it's not factorable. Are you with me? So the what you guys need to see long division as, and this is really what its main purpose is it's the last resort for factoring. So if all of your other traditional methods of factoring don't work, if it's still factorable, long division can do that for you. The issue is with long division, if you're going to factor using that method, you need to be told what to start with, right? You don't have to be. There's a way, and we may get into this, that you can figure out some options and try it on your own. But in Algebra 2, you were told, factor this knowing that -2 is a root. So if you knew that -2 was a root, what would you divide out? X plus 2. And when you do that, I'll just cheat, you're going to get x squared plus x minus 12, because you're going to get a remainder of 0. Well, I made the problem up, so I already know what the factors are.
Then you got to factor the top.
So what if you get a remainder of 0, you need to realize, just like when you do long division, this times this gives you 842, right? This times this gives you that. So what you have essentially done is you've just successfully factored this, even though it wasn't groupable. You've factored it into a linear and a quadratic, and once it's in a quadratic, you can do the rest of that by hand.
Yeah.
Groupable?
I love math.
You do?
I love it.
Groupable, I'm sure, is not a word.
I bet it is. Groupability.
I should call my
You
dad
think
and ask him.
groupability is a word?
Yeah, you think groupability is a word?
Well, let's